countries. They first became widespread in the late 1960s. Although they're often a bit smaller than their Western counterparts, there are over 3,000 shopping centers in Japan today. How to generate electricity can be a contentious issue these days. Fossil fuels are limited in supply, and greenhouse gases are contributing to global warming. Nuclear power comes with its safety issues, and alternative energy sources like solar panels and wind turbines are still not efficient enough to meet all of our energy needs. Today's special report focuses on a device which produces enough electricity to power a computer using the oldest energy source known to humankind, fire.
Here in Japan, it's still winter, but that doesn't keep hardy nature lovers from going camping. There's a bit of snow left on the ground and the temperature is a chilly 5 degrees Celsius, perfect for a nice steaming cup of tea. A pot is boiling over a fire, but this is no regular pot. There's a cord coming out of the handle. What could it be for? The end of the cord is equipped with a USB connector for supplying power to a smartphone. The pot is actually a power generator which uses heat to produce electricity. It does so with an internal thermoelectric element which works by making use of differences in temperature. The pot is the creation of a startup called TES New Energy. The company is affiliated with the National Institute of Advanced Industrial Science and Technology Kansai Center.
発電鍋はですね、DC 電気をですね、携帯電話に、の充電に直接使おうということを、でやり始めたんですけれど、発電鍋のお客様がだんだんもっと大きな電気をということを、言われてきまして、そうしますと発電鍋の上の、高機種ですと、20ワットぐらいの電気が出るようになって、それですと iPad とかですね、そういうものを動かせるようになったんですけど、あるお客さんがコンピューターを動かしたいという、そういうご要求があったので、それに対応するためには、発電鍋ではちょっと難しいと、限界があるということで、ファイヤーパーを作ったということです。
The company's new system, called Firepower 40, is contained in this case. The right side of the case has assorted outlets, including ones for 100-volt AC power and 12-volt DC power, and USB connectors. The system can provide enough power to run a laptop computer. This is the main component of the system. The 17-centimeter square heat unit is designed to absorb heat and conduct it to an internal thermoelectric element. We place it on top of a wood stove. Within minutes, the system starts to generate electricity. The temperature of the fire is about 450 degrees Celsius. The bottom part of the heat unit is about the same temperature. However, the temperature inside it is much lower, about 30 degrees. The top feels only slightly warm to the touch. This large temperature difference of over 400 degrees between the bottom and the inside of the heat unit is the key to thermoelectric power generation. A thermoelectric element is made of two different materials. When the two materials are at different temperatures, electron transfer occurs and power is generated. Conventional thermoelectric elements only work within a narrow range of temperature differences. The new element can withstand much larger temperature differences and thus generates much more power. Thermoelectric elements generate power in proportion to their size, so can be used in large industrial ovens as well as small pots.
熱電素子のシステムっていうのは構造を簡単にしないと熱応力とかそういう問題がありまして非常に難しいシステムになってしまいますので、できるだけ構造を簡単にしようということに注力しました。どういうふうに冷やすかと、熱を集める方と熱を移動させて、そしてその熱をですねどっかに持っていくと冷やすという技術が3つ一緒にならないと熱電のシステムというのはうまくいきません。で今回はどうやって冷やすかと いうことを結構考えました。
A pair of plastic tubes and a power cable extend from the unit to the stream running nearby. A small pump is attached to the other end of the cable. One tube draws cold water from the stream to the unit, while the other discharges water heated by the unit back into the stream. The system can be used to create hot water by circulating the same water from a bucket repeatedly, instead of drawing water from a stream. The system can also be used to power a water purifier. So just how much power can the system generate? Right now, the screen shows a voltage reading of over 12 volts and current reading of 2 amps, for a total of around 25 watts of power. Adding more wood to the fire increases the power generated. According to the company, the system can generate up to 40 watts stably. Let's plug 2 LED lamps into a power strip connected to the AC outlet. There's plenty of power for them to fully light up. We also plug in a small 20-watt laptop computer, which runs without any problems. The system generates enough power for a small outdoor office.
系統電源に頼らないその一つの道具として、世界中の人に使っていただければなというふうに思います。そして、系統電源がないところって日本ではアウトドア仕様ですけれども、やっぱりアフリカとかですね、16億人の人ぐらい、電気にアクセスできませんので、そういうところで僕ら電気のそのシステムを構築できればありがたいかなというふうに思っています。
The company's high efficiency element was originally developed for industrial use, but has now become available to consumers. Whether for camping use in industrial countries or for daily use in non-industrial ones, the technology's future has bright potential.
I think what appeals to me the most about the firepower device is the ability to produce your own power quite easily without having to rely on the power grid. I have a feeling that this sort of personal energy generation may play an important role in meeting our future energy needs. That's it for today's edition of Great Gear. Thanks for joining us. We'll be back next week with more stories about Japanese business and design. Until then, I'm Yoshi Ogasawara. Dewa.